Hello folks, welcome to my channel Java Demystified by SSR. Here comes the question number 23. What is dynamic method dispatch in Java? Explain runtime polymorphism. This is one of the most frequently asked questions in Java interviews. Let's demystify this question. So runtime polymorphism or dynamic method dispatch, both are same. So let's not confuse a dynamic method dispatch and runtime polymorphism. Both are same and which will happen at runtime. So JVM is responsible for doing this activity, not the compiler. And this dynamic method dispatch or runtime polymorphism based on the fact that the objects of subclasses are a special kind of objects of a superclass. So this is a rule in Java. The objects of subclass are a special kind of objects of a superclass. Let's understand this. Let's assume I have two classes. I have class A and class B. From class A, I have an object, and this is my parent object, and then from class B I have other object. This is my child object. Okay, so before this there exists inheritance relationship between these two classes. The first one is my class A, which is my base class, that is a parent class, and this is class B, which is a derived class. That means the class B acquires the properties from the class A. Now what this rule says is objects of a subclass are special kind of objects of a superclass. Let me write over here. So now I am creating an object of class B. So how to create directly B? Some object B1 equals to a new B. The subclass object has been created, and I have a parent class object also created. Let's say A1 equals to a new A, right? Now what actually can happen is the objects of subclass are special kind of objects of a superclass. Now what I can do is I can actually make my child object, that B1 is getting referred with A1, is getting referred with A1. So that means A1 was assigned B1. That means what? So A1 now refers to the child object, that is B1. So this is because the objects of the child class are a special kind of objects of parent class. Otherwise I can actually make up a statement like this. I can say A2 equals to new B. The object that is getting created here is child object, and which is being referred by a reference variable A2 of type A. The parents can actually refer to their child class objects. The parents can actually refer to their child class objects. This is possible. So that's what this rule. Objects of subclass are special kind of objects of a superclass. You can have an object of child class and which is being referred by parent class. We know in Java object class is superclass of all Java classes, right? So now any class object can be referred by object class. You can always write like this. We can say object some O equals to any class object. For example, new A or new A or new student, new customer, whatever it may be, because objects of child classes are special kind of objects of parent classes, and object class is the superclass of all Java classes. So based on this fact, actually we have the runtime polymorphism or dynamic method dispatch possible in Java. And this process actually, so referring child objects with parent references is called upcasting. Okay, so this statement actually A1 equals to B1. Otherwise, A2 equal to new B, where A1 is of type parent class A and A2 is of type parent class A, but both are referring to child class objects, right? So this process actually is called upcasting in Java. Okay, so upcasting is possible in Java, but not the downcasting. So parents can refer to their child object. Okay, so based on this fact and the other fact, that is overriding. So overriding is possible through polymorphism in Java, and overriding may lead to runtime polymorphism. So here, what is overriding? Overriding is a mechanism that allows a subclass to provide specific implementation of a method that is already provided by one of its superclasses. That means redefining the behaviors derived from a parent class in the subclass. Okay, so whenever these two things exist, whenever these two things coexist, whenever a overridden method is there and whenever parent is referring to a child object, okay, then dynamic method dispatch or runtime polymorphism will happen. Okay, so what is dynamic method dispatch or runtime polymorphism? In this process, it is a process wherein a call to the overridden method is resolved at runtime. A call to overridden method is resolved at runtime rather than at the compile time, is dynamic method dispatch. So while dynamic method dispatch taking place, what actually happens is a overridden method is called, but through superclass reference. A method is called with a superclass reference. A method is called through a superclass reference. A overridden method is called through a superclass reference. That means what? A overridden method exists in a subclass, right? And that subclass method, that is overridden method, now is called through superclass reference variable. Okay, during that time, the determination of the method is based on the object being referred rather than the type of the object. So this determination will happen by the JVM whenever a overridden method is called by superclass reference variable, and which method has to get executed or which method has to be bounded for execution, whether it's a parent's method or a child's method, because it is called through parent reference. And in a child class, you will have parent version of the method and child overridden version of the method. So you have two bytecodes available, directly parent method bytecodes and redefined bytecodes of that method. And that method was called with superclass, that means parents class reference variable. Now which method has to be bounded for execution? So that has to be resolved, and compiler could not able to resolve because the type mismatch happens over there. The object is of child class but the reference is of parent type, and this is the ambiguity for compiler. Whenever this ambiguity was there, simply it leaves it for the JVM to take care. And now JVM handles the situation. How it handles is, it determines the method to be called or to be bounded for execution based on the object being referred rather the type of the object. The object being referred will be the child class object. So child specific version of the method is going to get executed. So this is what happens in dynamic method dispatch or the runtime polymorphism. So let me explain the same thing with a programming example. For that, let me clear all these things. Yeah, let me go to my class actually. Here I have a class employee where I have 4 data members. One is static member. Then I have a method to set the instance members of this class employee. Then there is a cal salary method which calculates salary based on the basic pay. And there is a get employee method which provides me the details of the employee. So this is a base class and a non-executable class because there is no main method over here. Now inheritance should be there for dynamic method dispatch or runtime polymorphism. Now here comes the subclass, that is tech employee, which extends employee class. Whenever it extends, all the data members are available here. So all are non-private, so all non-private will be available over here. The child class has one added feature, that is bonus, which equal to 10,000, and a child specific method get bonus. Because this technical employee is having bonus in addition, so while calculating the salary, that bonus also has to be added. So the derived method has to be overridden. So overriding takes place for cal salary method. The same process, get employee method is also overridden because bonus has to be printed whenever we are printing the details of the technical employee, whereas bonus was not available for a general employee. So there was no bonus over here, so this bonus has to be printed. So two methods have been overridden. Okay, so in order to have runtime polymorphism or dynamic method dispatch, we should have a overridden method, and that overridden method should be called with a parent reference. Okay, so now let's see actually in the main method. Okay, so now I have an employee object. Of course, these things I am deleting. So as of now, I don't require for this. Yeah, so what is important here for me is this thing. Yeah, I'm creating a child object. I'm creating a child object. Technical employee TE1 equal to new technical employee. So here there is no difference. It's a normal creation of an object. Okay, but what I'm doing here, what change I'm doing over here is this T1 I'm actually making of type employee. The object that is getting created is technical employee, but referred by T1, which is of type employee. Okay, so parent class reference variable is actually pointing to the object which is created. So this is actually something like this. So let me annotate and tell you. So here we have an object created. Here we have an object created. Yeah, let me create this object. So this object is of type employee. So what object has been created? So technical employee. So the object is of type technical employee, and it's been referred by a local variable. So that is main method. We have local variables, right? So local variable is T1, which is T1 of type employee. So let me write this one. So this is T1 and which is of type, yeah, let me write its type also. It's of type employee. Okay, so now this T1 actually referring to this particular object. This is possible by the rule in Java. What is the rule? We understood actually here. The rule is the objects of subclasses are special kind of objects of a superclass. So this object is now a special kind of objects of superclass, that is employee or EMP, whatever it may be. Okay, so that EMP stands for employee for me. Okay, yeah, so this is actually EMP class, right? So I don't have employee, this is just EMP. EMP T1 equal to new tech employee. Okay, so now we are actually calling, so this is a normal method, this has not been overridden, so this is a normal method, but here I have a overridden call actually. So cal salary method is a overridden method and get employee method is also a overridden method. Okay, now what is actually happening here? So now this overriding leads to runtime polymorphism or dynamic method dispatch, and this also leads to runtime polymorphism or dynamic method dispatch. The reason is, in order to happen dynamic method dispatch, you should have a overridden method. So I have two overridden methods, and which are being called by superclass reference. Okay, so what is the problem now? Why dynamic binding takes place here? Why dynamic method dispatch will happen? See, here, how many cal salary methods are there in the child class, that is technical employee? We have two methods, right? So one cal salary. So let me write actually here. So we have two cal salary methods in the technical employee class itself. So we have cal salary, which is actually from employee class, and we have cal salary, which is actually uh, from this tech emp. Okay, so this is actually overridden method. Sorry, this is actually derived method. So this is derived, and we extend this, and this is overridden. This is overridden method. Okay, so now this cal salary method being called an T1. So for the compiler, it checks whether cal salary method is there. Yes, compiler finds actually two methods: cal salary, which is derived from its parent, and cal salary, which is overridden method. Yes, bytecodes are available in the class area. This is the class area. Now, which is called an T1 actually. So compiler checks T1. So T1 is a reference variable of type EMP, that employee EMP, right? But T1 actually referring to what? A technical employee object. And there are two methods. So T1 is of type employee. So the cal salary method of this employee to be called, or the cal salary method of this object tech emp or child specific method bytecodes, whether this method is to be called or whether this method is to be called. So compiler checks actually for strict typing. So the type of the variable T1 is of type EMP. Okay, so it's supposed to call actually this employee version of this cal salary. But in Java, whenever this ambiguous situation arises for the compiler, it was told to the compiler that it should not raise any error but leave it for JVM to handle. In the ideal case, compiler has to provide an error because it comes to an ambiguous situation. But whenever there is an inheritance, whenever there is an overridden method, whenever that overridden method is called by super type reference variable, it was told to leave to JVM for handling the situation rather than handling by compiler itself. So that's why compiler leaves it for JVM to take care. Now JVM comes into the picture and JVM checks. So this is method actually. Cal salary method was there and two versions are there. So which method to be called? So it just determines the method to be executed based on the fact that which object is being referred. Let's not worry about the type of the reference variable. Which object is being referred? The object being referred by this T1 is a tech employee object. Then call tech employee version of the method, or tech employee method, or tech employee's implementation. So tech employee's method implementation is an overridden method, right? So instead of calling, or instead of getting confused with the method bytecodes, JVM simply decides based on the object being referred. The object being referred by T1. So T1 is referring to tech employee. Let's call tech employee's version of the method. that is the redefined version. So overridden method is now getting called. So it just ignores the type of this super type variable, and it determines by the fact that, so it determines by the fact that the object being referred. The object being referred here is a technical employee, and let call the technical employee's version of that particular method. So now what happens here, the technical employee's version of this cal salary is this, and this is going to get bounded and executed for get employee, and this is going to get bounded and executed, rather than calling actually this cal salary and this get employee versions of the parent. Okay, so this is what actually happens during runtime polymorphism or dynamic method dispatch. Okay, so what actually happens during dynamic method dispatch, a call to overridden method will takes place through a superclass reference, and the method to be bounded for execution is based on the object being referred rather the type of the object. Okay, so that's what happens during the dynamic method dispatch or runtime polymorphism. Okay, so now let's execute this and see. Yeah, before that, let me clear all these drawings and let me save this. Yeah, so employee T1 equal to new tech employee, and we are calling T1.setEmployee. So this is not an overridden method. So then we have two overridden methods which are being called with the T1 super type, but object being referred is tech employee. So cal salary and get employee versions of methods of this subclass version has to get executed. Let's see whether they are getting executed or not. So save this, go to the terminal. So let me compile java c emp.java. So compiled successfully, and then java c tech emp.java, and compile successfully. There is no problem. So now let's execute tech emp java tech emp. Now salary printed actually here, and yeah, so set employee 110, so that we are actually getting, and get employee overridden, and we are actually getting the details of 110 xyz and salary based on this 69,000 into 55% plus this 10,000. So we are actually getting the details of the child class only, or the details of this class tech employee and its overridden behaviors. Okay, so runtime polymorphism took place here because we have overridden methods and we are calling through superclass references. Okay, so now what actually can happen is this program can be extended like this also. So I can actually have an employee reference, employee some E1 actually. So E1 actually now referring to my parent. E1 is of type my parent class, right? Now what I can do is I can actually make up this E1 equals to TE1. Okay, so now what actually I am doing, this is also called upcasting. So what I am actually doing is I am assigning the references. Okay, I am assigning references. When I am assigning these references, what actually happens? Now my parent now are referring to child object. So this is possible, right? So this statement is possible. Employee E1 is of type employee, and I have made E1 equals to E1. Okay, and yeah, so and I'm making one more statement. So tech employee. So here I am creating the object of child itself. So tech employee T1 equal to new tech employee. So here direct the child class object is created and it is referred by child type only. So now T1.setEmployee, T1.cal salary, T1.get employee, all these things definitely will be child specific versions only, because I am not actually calling through a parent reference. Okay, so here now this will not be leading to runtime polymorphism or dynamic method dispatch, because T1 is now not a parent reference. Okay, there is no dynamic method dispatch or runtime polymorphism, and there is no ambiguity as well to my compiler, because object created is take employee and reference is of type take employee and methods are available and binding will happen. There is no problem. But here whenever I say emp e1 and e1 is referring to te1, and now with e1 actually e1 dot set emp, e1 dot set emp, and I can actually have so 100, then I have some ABC, and then salary is 69,000 itself. Okay, so now I can call actually all these methods e1 dot cal salary and e1 dot get emp. So these two methods have been called. Okay, so now this case what happens now? So this case, this is not a overridden method. Set employee is not a overridden method, but this is a overridden method and it leads to runtime polymorphism or dynamic method dispatch. So here this is a overridden method, again it leads to runtime polymorphism or dynamic method dispatch, because cal salary is a overridden method and we are calling actually through e1. E1 is of type employee, so whenever there is a call to overridden method with the parent type, super type, runtime polymorphism takes place. During that, compiler will not bind the methods and it leaves for the JVM to take care, and JVM resolves the method call by identifying the object being referred. Okay, so even though type of E1 is employee, it is referring to TE1, and TE1 is actually technical employee object. It is referring to technical employee object. Okay, so JVM determines this method call by referring to the object. The object is of technical employee, so the technical employee specific methods will get executed. So now the first, these details and these details should be same actually. That means, yeah, so whatever cal salary and whatever get employee details you will get will be similar to this thing, even though the data is getting changed. My salary is actually 69 here and 69 here, so the outcomes will be same. So let me show you that. Yeah, so Java C techemp.java and then execute that. Yeah, now you can see, if you observe the salaries actually, so here I gave 69,000, here I gave 69,000, so same salary got it. That means here also child specific version is getting executed, and here there is no doubt child specific version only will get executed for this case. And for this case, even though runtime polymorphism taking place, our dynamic method dispatch takes place, the resolution is actually towards the child specific version of these methods. So that's why you can actually get the details. The salary getting printed is equal to same in this case and in this case. Okay, but the employees are different, but the salary is same. So we can actually understand that runtime polymorphism has taken place over here. Okay, I hope you have understood dynamic method dispatch, or it also called as runtime polymorphism, properly. Otherwise, just have a summary of the same. So runtime polymorphism or dynamic method dispatch is based on the fact that objects of subclass are special kind of objects of superclass, and overriding should take place. And whenever a overridden method is called through parent class reference, the binding will take place at the runtime. Okay, and the method that is going to get executed is based on the object being referred rather than the type of the object. Usually compiler has to do the binding, but this case dynamic binding will happen at the runtime by JVM. Okay, that's why we call this as dynamic method dispatch. Hope you have understood this concept clearly. If you have understood clearly, please like my video, share to your friends and colleagues, and subscribe to my channel and click on the bell button so that you can actually get more videos. Thank you.